All right, last class we multiplied and divided rationals. Today we're going to be adding and subtracting rationals. And in order to do that, we really need to review how to do it with numbers before we go into the variables, because the process is the same. So we said when we multiply, like this one here, we multiply straight across. And so we get 12 over 18. And then we can reduce that to 2/3. When we divide, we're doing the same thing. Here, we're just changing it to multiplication first. By keeping the first fraction, changing division to multiplication, and then flipping the second fraction. And then we multiply across, and we get 3/4. Well, when we add and subtract, before we can get started on that, we have to get a common denominator. So looking at 1/2 and 2/3, we have to get a denominator that works for both 2 and 3. So we're looking for the lowest common multiple. 2 and 3 can both be 6. So I can change both of these fractions to have a denominator of 6. The way we did that is we multiply this 2 times 3. So whatever we do to the bottom, we also have to do to the top so that we're not changing the value of it. So we get 3/6. For this second one, we multiply times 2. Again, whatever I do to the bottom, I do to the top, so I get 4/6. And then when we add, we keep the denominator and we add these numerators. 3 plus 4 is 7. That is also going to be true for when we subtract. So 3/5 minus 1/7. I need to get a common denominator here. And so the common denominator between these two would be 35. In this case, I multiplied 5 times 7 to get 35. And so I'm going to multiply 3 times 7 and got 21. I multiplied this 7 times 5 to get 35, so I'm going to multiply the 1 times 5. When we subtract, again, we keep this denominator and we subtract the numerators. And we get 16/35. And that's where we would leave it. Those two processes are the same ones we use with our rationals with variables. We are going to get a common denominator and add or subtract the numerators and keep the denominator when we're adding or subtracting, or we multiply across and keep change flip for multiplying and dividing. All right. However, these are a little bit harder to get a common denominator with. So we'll start with the ones that already have a common denominator. So when we're adding, again, we keep this denominator and we add the numerators. So x plus 2x gives me 3x. And then there's no constant here, so 0 plus 4 is 4. Just as a reminder, you cannot simplify this. Don't try and cancel these x's out. Because the plus is there, you would break order of operations. So this is as far as we can go. That does not reduce any further. They would have to be exactly the same factors in order for those to reduce. For subtraction, same thing here. We keep that denominator. And then we subtract the top, x minus 4. In order to reduce this, I would have to factor to see if anything reduces. So x plus 4, x minus 4 on the bottom, because that's the difference of two squares. Now these two are exactly the same factor, so that can cancel. That entire x minus 4 cancels the x minus 4. So we've reduced this to 1/x plus 4. All right, most of the time you're not going to get this common denominator, so we are going to practice finding that common denominator first. All right, we're going to look at this first one. In order to get a common denominator between these two, we want to think about what both of these can go into. And so for these two, that least common denominator would be an x plus 4 that this can divide into, and an x minus 4 that this one can divide into. So that's going to be our least common denominator for each one of these. And all we're doing on these are just getting common denominators. So I'm going to make both of these denominators x plus 4 and x minus 4. Sorry about that, wrote a plus there. Now that we have the denominators we need to do exactly what we did with those numbers. So to get from this denominator to this new one, we multiplied times x minus 4. So whatever I do to the bottom, I'm going to want to do to the top. So I do 3 times x minus 4. For the second one, to get from this denominator to this one, we multiplied times x plus 4. So I'm going to want to do the same thing to the 7x. So I do 7x times x plus 4. That way we're not changing the value of the fraction. All right, for this second one, to determine the least common denominator here, I'm really going to want to factor this so that I see what is in the denominator. So when I factor this bottom part here, I get x plus 2 and x plus 3. Now we can determine the least common denominator. I need an x plus 2 for this first one. For this second one, I need an x plus 2. Well, I already have one. And then I need an x plus 3. So we're going to multiply those two together. This whole thing goes into this, and x plus 2 goes into that first one. So that would be my least common denominator. If you put x plus 2 times x plus 2 times x plus 3, they both could go into that, but that wouldn't be your least common denominator. And you really want the least one so you don't have to reduce much at the end. All right, so we've got x plus 2 and x plus 3 as my new denominators. To get from this denominator to this one, we multiplied times x plus 3, so I need to do the same thing in the numerator. Now to get from this denominator to this one, I did nothing because that's what it already had, so I do nothing to the top. All right, we'll do one more together. We'll go ahead and factor this. All right, once it's factored, we determine that least common denominator. And so I need a 3x minus 2 for the first one. I need a 3x minus 2 for the second one. I've already got it, so I don't have to repeat myself. And then an x plus 3. Again, from this one to this new one, I multiplied times x plus 3. So I would multiply that negative 2 times x plus 3. I didn't do anything to the second one, so I'm not going to do anything to the top either. All right, we are going to go ahead and do one more because this one here is a little bit different. So step 1, I factor. That allows me to see what I have in my denominators currently. Now I find that least common denominator. I need an x minus 2 and an x minus 3 for this first one. For the second one, I need 2 x minus 3s. One of them is covered right here, so I would need one more. So our new denominator is going to be x minus 2, x minus 3, x minus 3. Now, to get from this denominator to this one here, we multiplied times an x minus 3, so I would multiply the 2x times an x minus 3. To get from the second one to this new one, I multiplied times an x minus 2. This is the part that was missing right here. So I'm going to multiply that top times x minus 2. And you would have to FOIL here because you're multiplying the entire numerator you had times the new numerator. So keep that in mind. All right, now we're going to actually try and add and subtract some. We'll start with some of the easier ones and then move to some that are a little bit harder. All right, for this first one here, I would factor a 3 out. You always want to factor just to make sure you have that easiest lowest common denominator. Our lowest common denominator in this case is 3 times x plus 3. That's what I need for this first one. I've already got an x plus 3 here, so I just need to multiply times 3. So this one should be nice and easy to start with. I multiplied the bottom times 3, so I need to multiply the top times 3. So 2x times 3 gives us 6x. Now we said when we are adding fractions, we keep the denominator and we add the numerators. There's no x term here, so it'd be 0x plus 6x, which is 6x. And then there's no constant here, so 8 plus 0 is 8. You can factor now the top. There's a greatest common factor of 2 there, so I can factor out a 2. The reason I do that is to see if anything reduces, but these are not exactly the same, so there's nothing that can reduce, so that's my final answer. All right, we'll move to one that's a little bit harder. So here we've got x plus 3 and x plus 2. Hopefully you're really good at that factoring because you're going to need it so much for this unit. All right, for our least common denominator here, I'll go ahead and write it out to the side. We need an x plus 3 with an x plus 2 for this first one. That covers all of that. Now I need an x plus 2. Well, I've already got one right here, and another x plus 2, so I need a second one. Now this whole thing will go into this, and that first one goes into this first part, so we're covered. All right, we've got our denominator set up. Now to get from this first denominator to this new one, we multiplied times x plus 2, so I need to multiply the top times x plus 2. To get from the second denominator to the new one, we multiplied times x plus 3, so we need to multiply the 2 times x plus 3. I'm going to go ahead and distribute this now so that we can subtract. And so x times x gives us x squared, and x times 2 gives us 2x. I'm just going to go ahead and write some quotations so I don't have to write all of that out and waste your time there. 2 times x gives us 2x, and 2 times 3 gives us 6. All right, with subtraction, just like addition, we keep our denominator. And then we go ahead and subtract the top. So x squared minus, there's no other x squared term, so that just stays as x squared. You want to remember to subtract everything in the second one. So that is 2x minus 2x, which is 0x. And I don't have to write that. And then the constant here would be 0. So 0 minus 6 is negative 6. A lot of students miss that, the second ones after that x squared, because they always remember to subtract that first one, but they forget to subtract all the way through. So you want to remember 0 minus 6 gives you that negative 6. All right, we're going to move to some in the back here. Actually, we're going to do one more down here. And for this one here, I do not have to factor because that doesn't factor. So I can go ahead and go into my least common denominators. I need an x minus 4 and a 3x minus 1. We multiply this top part, x plus 2 times 3x minus 1. And then we multiply that 5x times x minus 4. A lot of times people are like, oh, that reduces. They're exactly the same. Cancel out. Yes, that's true. You can cancel it out to become 1. But then you're back at the starting point. So you don't want to cancel these until you get to the end part. We put those there on purpose so that we're able to add them. All right, in order to do this now, and I'm going to go ahead and write quotations while we take care of that top, you have to FOIL the top part. So we get 3x squared plus 5x minus 2, and then 5x squared minus 20x. All right, now we keep the denominator. So I'm going to keep that denominator of x minus 4 times 3x minus 1. And we are going to add the numerators. So 3x squared plus 5x squared gives me 8x squared. 5x plus a negative 20x gives me a negative 15x, and negative 2 plus 0 is negative 2. Just like with the other ones, if there is something that can factor up here, you're going to want to do that to see if there's anything that cancels. So I factor that out, and I get 8x plus 1 times x minus 2 over x minus 4 times 3x minus 1. There is nothing that cancels here, so that is my final answer. You can only reduce if they're exactly the same factors that will cancel each other out. All right. One of the things that we haven't talked about is restrictions. So most of the times on tests and stuff, you will have the restrictions that you'll need to write. And that is what x cannot be in these problems. So anything that was in the denominator and would make this 0, you would have to consider a restriction. So for example, in this first case here, we had x plus 3's in the denominator. So x would have to be unequal to negative 3. Because negative 3 plus 3 is 0. That would cause a 0 in the denominator. So on a lot of the tests, you'll see those restrictions. In this case here, you would have 3 restrictions, negative 3, because it cannot be 0, negative 2, because that would make that one 0, and actually that other one is the same thing, so it'd just be those 2. But you're looking for whatever makes it 0, that would be a restriction, so keep that in mind as well. All right. We'll look at some that are a little bit harder now. I factor, and I get x plus 1 times x plus 1. I have to factor this one as well. That's x plus 1 and x minus 1. Now that it's all factored, we could go into finding our least common denominator. One of the things that you are going to want to look out for, like on this second one here, you see that now that we've factored it, there's an x minus 1 and an x minus 1 here. We can go ahead and reduce that now so that we can find a smaller least common denominator. Also, if you continue to look and you remember you're factoring, there's a greatest common factor here, so that can actually reduce to 3 times x plus 1. And then you can actually take one of these out. But you've got to be really careful with what you're looking at and noticing that those are exactly the same. All you did was avoid a little bit of extra work there, because now you notice they both already have the same denominator. So that's 3 over x plus 1 over x plus 1. And so 3 plus 1 gives us 4. And then you keep the same denominator. So we add that 3 plus 1, got 4, and we keep this denominator of x plus 1. All we did there was reduce at the beginning instead of at the end. So that just helps you out with how much work you're going to do. If you wouldn't have noticed that, you could have just added like normal, got a common denominator, and then just reduced at the end. All right, number 14 here. We factor, we get x plus 3, x minus 2. We factor the second one and get x plus 3, x plus 1, and then the last one can't be factored. In this case, there's 3 of them. You're going to have to get a common denominator between all 3 of them. So I need an x plus 3 and an x minus 2 for that first one. I need an x plus 3, which I've got, and an x plus 1, so I'm going to have to include that in my denominator there. And then I need an x plus 3, which I've already got, so I don't have to repeat that one. You really want to get that least common denominator, because if you don't, you're going to have a lot of extra work. All right, now that we've got the denominators the same, I need to do whatever I did to the bottom to the top. So I multiplied this bottom times x plus 1, so I need to multiply this top times x plus 1. I multiplied this second one times x minus 2, so I need to multiply that top times x minus 2. And I multiplied that last one times x minus 2 and x plus 1, so I need to multiply that top times x minus 2 and x plus 1. You want to make sure that you include everything you multiplied on the bottom there. And again, if you think about this and this cancel and you're back to that original, these two cancel those two and you're back to that original, then you've done it correctly. All right, so now we're going to have to FOIL all these top parts. So I FOIL x minus 1 times x plus 1. That's an easy one because that's the difference of two squares. I'm just going to put quotations, so I don't have to rewrite all that. And then I FOIL this one, and those are both the same, so that FOIL's pretty easy as well. X squared minus 4x plus 4. And then my last one, we've got 2x squared minus 2x minus 4. So we FOIL those two, and then we distribute it to 2. All right. For our final step now, we go ahead and keep the denominator. And we add or subtract the top. And in this case, we're doing both. We've got an addition here and a subtraction here. So x squared plus x squared is 2x squared minus a 2x squared is 0x squared. So those go away. Then I do my x's. I've got 0x here. Minus 4x is negative 4x. Minus a negative 2x. This is the one people mess up on, that minus. That will turn it into that plus. And so we're going to get negative 2x. So again, 0x plus a negative 4x gives us a negative 4x. And negative 4x minus a negative 2x gives us a negative 2x. Now we do our constant. Negative 1 plus 4 gives us 3. 3 minus a negative 4 gives us 7. That does not factor, so that is my answer there. All right, we'll go ahead and do one more. This one here looks scary, but it's not. It is a cool problem because it's got the addition, the subtraction, the division, and multiplication all in one problem. In order to do this division that we've got right here, we've got to have one fraction on top of one fraction. So we're going to have to take care of those first. So I need a common denominator up at the top, and I need a common denominator down at the bottom. I need an A for this one, and I need a B for this one. So my common denominator is going to be AB. All right, for the first one, I multiplied that A times B to get this, so I need to multiply the top times B. For the second one, I multiplied times A, so I need to multiply the top times A. The denominator here, those are actually going to be the same, AB and AB. For the first one, I multiplied times B. For the second one, I multiplied times A. Now I go ahead and add and subtract those. So here I've got an addition. I'm going to keep the AB as my denominator, and I'm going to add that numerator. So B plus A. In the denominator, I'm going to keep the AB, and I'm going to subtract, so I get B minus A. Now we're ready to do the division since we've got one fraction on top of one fraction. And so we said when we divide, we keep the top one there. And then we change to multiplication, and then we flip that second one. Now with multiplication, we can go ahead and simplify if something's in the numerator and the denominator. So we have an AB and an AB in both the numerator and the denominator. Now we're ready to multiply. And so B plus A times 1 is B plus A. And 1 times B minus A is B minus A. That is as far as we can go. So that would be my answer. So that was a cool one because you got to add, you got to subtract, you got to do the division, and you got to do the multiplication. So it's a fun problem. It's not a hard one. So you'll see it sometimes on SATs and stuff. It's just keeping everything together that you're supposed to do. If you were talking about the restrictions here, you would want to think about everything that A and B cannot be. So A has to be unequal to 0 because A was in the denominator here. B has to be unequal to 0 because it too was in the denominator. And they cannot be equal to each other because right here you are subtracting them. So if they were the same thing, that would give you a 0. So there's some more thought on those restrictions. And that's adding and subtracting rationals.